All right, so here we are. This is section 5.1. This is part 2. And we're going to start off with modeling polynomials. So I don't know, have you guys ever heard of or seen algebra tiles before? There are actually physical algebra tiles that we used to use a lot in class. And they were like see-through colored tiles, squares, long rectangles, and little tiny squares. And those are math manipulative. So we're going to use visual representations of algebra tiles. We're not going to have actual algebra tiles to throw around here in class. Not for this lesson, but we're going to sketch some algebra tiles to help us understand how to model polynomials, how to add and subtract polynomials, and that kind of thing. So in your notes, you'll see that algebra tiles can be represented by squares. A small square, one small square represents a positive 1, and that's a square that's not shaded in. And a rectangle like this would be a positive x. Okay, so anytime we need to represent a single x, we use this rectangle. And then an x squared, a positive x squared, would be this large square. Okay. Over here, the shaded figures here, so a shaded square, little square, is a negative 1. A shaded rectangle is negative x, and a shaded large square is negative x squared. Okay. Now, there is, the one neat thing about this that I'd like you to notice is that this x squared, okay, think about this, x times x. Do you guys know what we get when we multiply an x by an x? Have you ever seen that before?
X squared.
Yeah, you get x squared. That's right. X times x is x squared because you add the exponents. We're going to spend some time learning and studying these exponent laws as we move through math here, but you should have seen something like this before. So an x times an x is actually x squared, correct? Notice that this large x squared square has dimensions of this big long x, and also the width would be this big long x. So length and width would be this thing times itself. Okay, now that will come in handy a little bit later, but let's start from basics. In your textbook, you'll see that yellow tiles are positive, okay? Yellow tiles are positive, and red tiles, they don't shade it in, they just use yellow and red. Red tiles are negative. And the most common variable that we will use in math would be x, but you can use other variables like k or w or l or whatever. Okay? All right, so let's take a look at this. Match the following polynomials to the appropriate diagram. So if we were to represent, okay, the polynomials that we stated above, and you have those in your notes, a negative 2 x squareds. Okay, that's going to be some algebra tiles represented by that. And then minus 3, and that would be the same as writing plus negative 3. So you can envision A also like this. And whenever you see a subtraction, it's always the same as adding the opposite of that number. So where do we have 2 big shaded square tiles and 3 little shaded square tiles? Well, that would be down over here, looks like. Does that make sense? So they're all negative, 2 big x squared tiles and 3 little squares. Okay. All right, negative 3x minus 2. So all negatives again. And we need 3 rectangles, which I see over here. So there's minus 3x. And here's shaded little squares, minus 2. So this one goes here. All right, and finally, negative 2x minus 3. So that's going to be 2 rectangles that are shaded and 3 little squares that are shaded. Okay, any questions about that? No? All right, so let's draw these ourselves. Okay, so I am going to need to draw, it looks like 3 of the larger squared tiles. And are they going to be shaded or not shaded? What do you think? Go ahead and shout out the answer. Not shaded or shaded? Okay, not shaded because it's positive. Right, there's no negative sign in front. So let's go ahead and draw 3 squares. And you can do this on your notes. You have space to do this as well. So 3 large squares. And those should be the same size. It's really tough for me to do that, actually. I'm sorry, I'll try again. So 3 large squares that are not shaded in. Good. I need 2 x tiles. Those are the long rectangles. And should those be shaded or not? Shaded, right, because it's negative. So it doesn't matter how you draw them. They should be the same length as the squares, and we'll draw two of them just like this. Good. And then plus 5. So that is the small little squares and not shaded in, right? Okay, so let's go ahead and draw 5 of those. Awesome. Okay, any questions about that? Okay. Now, the algebra tiles are going to come in handy when we add, subtract polynomials, and also when we multiply and divide. So these algebra tiles, we're not just drawing pictures for polynomials and we're going to stop there. They're actually going to be useful to help us understand a few things when we add and subtract specifically. Okay. All right, x squared plus 3x minus 6. All right. That one should be 1 large square for the x squared. 3 rectangles. Again, these are all positive, so I'm not going to shade any of them in, right? And then I'm going to have 1, 2, 3, 4, 5, 6 little squares. And it's a minus 6, so guess what? All those should be shaded in. Okay? All right, now, sometimes I do this in class too for those of you that are new. Sometimes I say, okay, do you understand? And what I want you to do is I want you to give me either a 5, which is like, I fully understand this, 5 out of 5. I could teach this to somebody. This is baby stuff. It's so easy, 5, okay? A 0, hopefully nobody has a 0, but 0 is like, I actually don't speak this language, and I have understood nothing you said, and I have no idea even where I am, okay? It's like 0 is like, I don't get this at all. So somewhere in between, where are you in between? You don't have to show your friends, just show me. So out of 5, how are we doing with this so far? I'm just going to scan the room. Just show me. 1, 5, 4, 3. What do you think? Okay. What do you think? What's your, okay. Okay. Bad. Okay. Okay. I have fewer fingers on the choir kids that were gone for a couple days. I get that. It's okay. But, okay, good job. At least I can kind of see. If I see a whole classroom of 0s and 1s, I know I need to fix stuff, right? I need to figure something out, something different. If I see a room full of 5s, I'm going to probably quickly move on from this, okay? So you guys have got to help me here, okay? I can't read your minds. All right. Example 5. Okay, now we're going to go the other way. We're going to look at the tiles. We're going to write expressions. Shouldn't be that bad here. All right, so what do we got here? Well, I've got a big square. That's an x squared tile. It's shaded in, so it should be negative. I've only got one of them, so let's go negative x squared. What do you think? You cool with that? What about these ones? These tiles represent what? 1s or x's or x squareds. What are these again? These are x's, right? And there's 2 of them, good, and they're positive because they're not shaded in. So this is going to be plus 2x. Okay, all right. Now, we don't have any little squares, so I don't have to put anything for the constant, right? Because those little squares were the constant, remember? So I could put plus 0 if you want. If you're wondering what the constant is, that's a good way to envision that. You say, oh, the constant is 0 because I've added 0 little square tiles. So you don't have to write that, but that is how you determine what the constant is, okay? And yes, identifying the constant as 0 is going to be important, okay? Because a 0 as a constant is important in applications for math when you get up to grade 10, 11, 12, okay, when I see you there, all right? All right, you do this one on your own. Go ahead and write it down. Actually, the next 2, go ahead and do the next 2. I have confidence in you here. I saw a lot of fingers, so I think you know what you're doing. So go ahead and on your paper right now, on your own, go ahead and write the polynomials that represent B and C. And I will write my guesses on there as well, and I'll show you my guesses in just a few seconds. Okay. All right, let's see. Do you agree with my assessment of B and C there? B, anybody get that for B? Positive 3x minus 1? Yes, okay. What about C? Did anybody get that? Negative 2x squared for the big squares minus 4x plus 3? Yeah? Awesome. Okay, good. All right. That's where you that's where you should be there, right there. Okay. Good job. All right, what's next? Next page. Descending order. All right, let's talk about descending order. Now, in a polynomial, remember, polynomials are additions of individual terms, monomials. So if you have a monomial, you like add a bunch of them, that's a polynomial. You might see that there's subtraction as well. Now that's the same as adding a negative, so don't get mixed up with that. When you look at a polynomial, the terms are separated by a plus or a minus, okay? A polynomial should also be written in descending order whenever possible. This is going to be more important as we kind of move through math. That's the typical way of writing things. So think about this. There's a proper order to write the terms in a polynomial, just like there's a proper order to write the letters of your name, okay? If you were to jumble up the letters of your name and you wrote that in your paper, that would be very confusing. That's just not what you normally do, right? That's not even your name if you jumble it up. So in the same sense, there is a proper way to write the terms in a polynomial, okay? So generally. There's a lot of conventions like that, like typical things that we normally do to kind of smooth the process out of doing math. And I'll teach you about all of those, okay, in math. But one of the things is writing polynomials in descending order. So what does descending mean? Well, if you descend from, if you're on a flight, if you're on a plane, you know, the pilot might say, oh, we're about to start our descent. Would you please return to your seats and buckle your seatbelts? Descent. It means you're coming down, okay? You're coming down to land in the airport. That's what a descent is. So descending order means that the exponent of the variable, and usually this is easiest to do when you have one variable only, so it's the largest exponent is written first, then the next largest, and then the next largest. The numbers go down, descending, okay? So in this case here, let's remember to look for the variable and the exponents on those variables. All right. Oh, let's fill in this blank first, shall we? This means that the exponent of the variable should, what's the word you think should go in there, guys? Descend, or what's another D word that's maybe a little bit easier to apply here? Decrease, maybe. I would say decrease would be a best word there. Yeah. So the exponents on the variables should decrease as you go from left to right. And if you want to use the word descend, you know, down, left to right, that's great too. That's great too. Okay, so we're going to change this polynomial around so that it's written in descending order. And I'm noticing that this term right here has the largest exponent on its variable, okay? The k value here, the k exponent is 0 here. We talked about that first lesson. Because there's no k, that's the same as writing k to the power of 0. And so that one obviously is going to be lower than 2. And it's going to be lower than this one, which is 1. If you don't see an exponent on a variable, it's understood to be 1. Okay? So we're going to write the k squared term first. And this little don't forget that I've zoomed out of here, don't forget, be careful with your positive and negatives. The sign that comes before the term always goes with the term. It should stay with that term. The sign that comes before the term should stay with that term when you're rearranging the order. So that minus 4k squared in this polynomial should be written as negative 4k squared. Okay, so we're going to take care of this first. And then we're going to do plus 2k. And then finally the constant at the end plus 7. So the constant is always at the end with descending order. Okay? All right, what do you think about that? Any questions about that? Descending order. If there are multiple variables with multiple exponents, descending order isn't as important, I'll just be honest with you. Generally, the terms with the largest sum of exponents would then be written first, and then the next largest sum of exponents would be written next, and so on. But usually it's in descending order of one single variable. Okay? All right. All right. So let's rearrange these terms. So I'll do a few with you, and then you can do the rest. This one right here, I'm looking at the p's, and obviously p squared is the largest exponent. 2 is the largest exponent, so I'm going to write 4p squared. I'm then going to go over to this p to the power of 1, and this negative 2p is going to now show up as a minus 2p in here. You see that? The sign always goes with the term, and minus sign at the end. Thoughts on that? Questions about that? All right, I tell you what, why don't you do the last two? I have full confidence in you that you're going to be able to get this. So do the last two, which are right here. Rearrange those terms in descending order of the variable x in this case and c in this one. So go ahead, rearrange those just like I did with the first one so that they're in descending order. All right, so check your work with this one right here. See if, did anyone get the same answer for B that I got there? Yeah? See some heads nodding? Okay, the x squared term is going to go first, the x term is going to go next, and the constant at the end. Here, the c squared term is going to go first, then the c term, then the constant last. So, should look just like that. All right, let's take a look at this now. Let's put it all together. This last part of your notes here, we're going to ask about, which ones are monomials, binomials, trinomials, and so on. And we're going to ask for degree, and then we're going to write some in descending order. So let's tackle this right here. Okay, which polynomials in this list are monomials? Okay, that's the question. Which in this list are monomials? So let's just write the letters beside here. So remember, monomial is one single term. So what do you think about A? Yes or no? Yeah, it's one single term. That's right. So A is a monomial. What about B? I've got multiple variables here. Is that a monomial, or is it a binomial? Or is it a trinomial? It's a monomial because all of these values are multiplied together. There's no plus or minus in between these ones, okay? So this is, B is also a monomial. C, for the same reason, is also a monomial. D, what about D? Yeah, it is a monomial as well, because even though we have lots of terms, they're all multiplied together. Okay, so any other monomials in the list? Because E is not a monomial. What? Sorry? H, right. The term 100, that's just a single term, so H there as well. Okay, anything else? No, I think we got them all. Okay, binomials with two terms. So that's one term either added or subtracted, and another term, just two only. Where's the first one? E, very good. Okay. What about F? Ooh, this is really complicated. Is that a binomial? No, I see a minus here and a plus here. So actually this one has 1, 2, 3 terms. So we'll save that for the trinomial one. Other binomials. Ooh, what about this one? What about J? Is that a binomial? You bet. J is a binomial. Not K. L is a binomial. Good. And these other ones have way too many terms. So E, J, and L. Excellent. Okay, which are the polynomials that are trinomials? Well, I mentioned one here. This F looks like it has 3 terms, even though it looks pretty complicated. But F, any other ones that have 3 terms that we missed? And, okay, I has, let's take a look at I. 1 plus another one plus another one minus another one. So guess what? That one actually has 4, so it's just K is the other one right here, F and K. Okay. The other polynomials with 4 terms, they are, what are they called again? We talked about that last day. Quadrinomials, that's right. You don't run into that very often. There would be names for polynomials of lots of different numbers of terms, but monomial, binomial, trinomial, really the only ones you have to know, okay? So yeah, the ones with 4 terms are called quadrinomials from last lesson. You can look that up. All right, number 4, write the degree of the polynomials beside the polynomial. So for those of you that haven't watched yesterday's lesson, if you were away, we talked about degree of a polynomial, and that is the largest exponent on a single term, on a single variable expression, or it's the sum of the exponents for a single term in an expression, the largest. Okay, so the degree of this, of A, is going to be what? It's 5, right. The degree for A is 5 because it has one variable and the exponent is 5. This one has 2 variables, so remember we add the exponents. So what's this degree? 3 plus 8 is 11. Yes, you're right. Yeah, you're right. No, I wasn't saying you're wrong. I was just walking it through there. Okay, what about C? I'm sorry? 3, yeah, because we have 1 plus 1 plus 1 is 3. Okay. I'm going to zoom in a little bit for you guys in the back. Okay, D. What about D?
6.
Okay, so some say 6, and somebody said 7. What do you think? What's the vote?
7.
Is there an exponent on this Z here? It is, and it's 1, right? Because remember, if it was 0, it wouldn't be there. So it's not 0, it's actually 1. So we do have to add up all of these numbers, even the one that doesn't appear there. So 2 plus 4 plus 1 is 7, right? Okay, so this one is 7. Very good. All right, E. Now again, we don't add up the exponents on different terms ever. This is just a one variable expression. So I look at the exponent, the largest exponent on the variable, and in this case it's 3, so the degree of this polynomial is 3. Okay? All right, F, confusing one, isn't it? But what we have to do is we have to add up the exponents on all the variables for each term. So this one is 5 and 4, that's 9. This one is 3 and 1, that's 4. This one is just 8. So what's the degree of this polynomial? It's going to be 9. Yeah. The degree only comes from a single term, so this one is 9. Very good, very good. G, shout it out. 3 is correct. Very good. Yeah, you don't add up all the exponents because they're in different terms. So it's 3a cubed here. That's the largest. Oh, you guys are awesome. Okay. Oh, what about this one? This is a tricky one. What's the degree here? Okay, I heard 1, I heard 0, I heard 0, 0. Okay. So variables. Remember, the key is exponents on variables. What's the variable in this? Oh, there is no variable. If there was a variable, what would the exponent on that variable be? Well, it would have to be 0 because it doesn't show up. You see? There's no exponent showing up, or there's no variable showing up. So if there was a variable, it would have to have 0. Okay? So 10x to the power of 0 is this, 100, x to the 0 is the same as just 100. So this is 0. Okay? So if there's no variables, if it's just a constant, it's 0. Just remember that. That would be good enough. Okay, let's go through these a little more quickly. I, what is it? 4. Very good. J, what is it?
3.
It's 3. That's right, the largest exponent there. K? 2. Very good. L? 4. M?
3.
Yeah, it's 3. All the terms technically have a degree of 3 there, right? 3, 1 plus 2, 2 plus 1, and 3. So this one is 3. And what about this one? 3, 3, 3, 3. Those are 3 as well. Excellent. Okay, the final thing we're going to do in this lesson here before I turn you over to your assignment from the textbook is number 5, write G and I in descending order. Okay, so if I look at letter G here, which term am I going to write first of all those terms? Which one do I write first and why?
4a.
Okay, close. It'll be negative 4a cubed that I'll write first. Remember that sign has to go with it. But yes, that's right. That's the term. And why? Why is that? Because it has the largest degree of all the terms, right? So perfect. So a cubed. Which is the next one that I should write? Right, minus 12a squared. That a squared term goes next. And then after that, plus 6a. And I'm kind of sensing that these negative positive signs are going to trip you up a little bit. So please remember that the term itself actually includes the sign that's just before the number. Okay? So that's why I wrote these first two with negative, and the third one with a positive. Okay? So what about the last one is plus 10. Let's just quickly double check. I have a cubed, then a squared, then a to the power of 1, then a to the power of 0. So that's totally descending order. We got it. All right? All right, you do GI. You do I. Where's I? Oh, you do I, please, on your own, right up here. Do I on your own, and I'll show you my guess in a minute. All right, when you're done, look up at the board and see if you've got this the same as me. So again, we're looking at I right here. And the term with the largest exponent on the variable is the x to the 4 there. So it's a plus x to the 4, so that's why it's a positive x4 that I write first. You don't have to write the positive sign for the very first term. You obviously have to write the negative sign for the very first term, but you don't have to write the positive sign for the first term, okay? The next one would be the cubed term, and that is the power of 3, and it's got a negative in front of it, so it's a minus. So minus x cubed, and then plus x squared here, and then plus x. You do not have to include the plus 0. Okay? You do not have to include the constant if it's 0. You just have to know that the constant would be 0 if asked. Okay? All right. Is this making sense? Okay, show me again the numbers here. Do we have 5 out of 5? Do we have 4, 3, 2, 1, 0? What do we got? Okay, I'm seeing a lot of fingers. That's very good. I do mention this to all my classes. If you have a 1, just don't use the middle finger to show me, okay? I might take that the wrong way. If you're a 1, please use your index finger only, okay? Or the thumb even. That's confusing, isn't it? It's like, thumbs up, you know what you're doing? Or are you a 1, okay? So, I don't know. This one's like, I'm a 1, but I don't really want you to know. Okay, that's, okay. All right, so you guys ready for your textbook assignment now? Show me what you can really do here. I'm going to give to you. All right, here we go. Okay, so page 214, number 4 to 14. You do not have to write, for those of you that are new to this class, you do not have to write out all of the questions from the textbook. You don't. You should write out, you don't have to write all the instructions. I would encourage you to write the question and then your work and then circle the answer. That's what I would encourage you to do. But you don't have to write out like the narrative, all the instructions. You don't have to copy out the exact whole question. But you should copy out what your, the question, your work, and the answer so that you can look back to your homework and actually learn something from it later and remember and study from it, okay? So I need you to show your work. I need you to circle your answers. And I need you to be somewhat neat about it because you are going to be handing this stuff in for me to look at. If I can't read it, it's going to be tough for me to give you marks on it. So please try and be neat and organized. It's a good habit to get into in grade 9 because it's the only thing that's going to save you in grade 12 calculus is if you can actually show your work and be a little bit neat about it because you're going to do a question that's going to be a whole page long. You're going to be writing a whole page. That's going to be one single question. And you're going to have to be able to be neat and orderly. So please work on that. Now, if you're not used to showing your work, if you're not used to explaining how you do a question, you need to start getting used to that right now. Okay? So that's your challenge for this assignment.